Hi everyone, my name is Keerthana and I am here to explain you Chapter 20 Basic Tools such as Dynamic Programming. Now, what is a dynamic programming? Let us see. A dynamic programming is most powerful design technique for solving optimization problem. Dynamic programming approach is similar to divide and conquer in breakdowning the problems into small and simple subproblems. Now, dynamic programming is used where we have problems which can be divided into similar subproblems so that their result can be reused. Mostly, these algorithms are used for optimization. Before solving the in-hand subproblems, dynamic algorithms will try to examine the result of the previous solved subproblems. The solution of subproblems are combined in order to achieve the best solution. There are two key attributes that our problem must have in order of dynamic programming to be applicable. Now, there are optimal substructure and overlapping subproblem. First one, optimal substructure. The optimal substructure means that the solution to the given optimization problem can be obtained by the combination of optimal solution to its subproblem. Such optimal substructure are usually decidable by means of recursion. The dynamic programming technique exploits this property to split the problem into small subproblems and solve them. Instead, this is useful because after the subproblems become sufficiently small, solving them becomes trivial. These trivial solutions can then be used to solve the subproblems and arrive at the final result. Now, next is let us see an example of a shortest path problem having optimal substructure properties. Here we can see a diagram which is having a source as 0. Now let us see the outputs should be. Let us see the distance from 0 to 1, that is the distance is 4 and the path is 0 to 1. Let us see the 0 to 2. The 0 to 2 path is from 0 to 1 and 1 to 2, that is the distance is 8 plus 4, that is 12. Next, let us see 0 to 3, that is distance from 0 to 3, that is 0 to 1, 1 to 2 and 2 to 3. Now 4, 8 and 7 becomes 19. So the distance from 0 to 2, 0 to 3 is 19. Let us see from 0 to 4, that is 0 to 4, that is now 0 to 1, 1 to 2, 2 to 3 and 3 to 4. That may be a path, or else we can take another path which is 0 to 7, 7 to 6, 6 to 5 and 5 to 4. We have obtained this path, that is 0 to 7, 7 to 6 and 6 to 5 and 5 to 4. And as we can see in the diagram, by adding this path distance we get the distance as 21. Now we have to see the path from 0 to 5, that is 0 to 5. The path will be in different ways, but we have considered 0 to 7, 7 to 6 and 6 to 5, that is 0 to 7, 7 to 6 and 6 to 5. Now adding the distance, that is 8 plus 1 plus 2 becomes 11. Now next let us see from 0 to 6, that is 0 to 6. that is distance will be 9, as I have said, that is 0 to 7 to 6. Now 0 to 7, that is 0 to 7. The distance between these two is 8. So the path is 0 to 7, distance is 8. Now let us see the path between 0 to 8. 0 to 7, 7 to 8. This may be a path, but we will consider 0 to 1, 1 to 2, and 2 to 8. So, by adding 0 to 1, 1 to 2, and 2 to 8 distance, we get 14. So, 4 plus 8, 8 plus 2 is 14. This is a basic simple example of the shortest path. Now let us see the counter example consists of large path problems. Source is U to the destination V. There are two longest paths from Q to T, that is Q to T, Q to R, R to T, that is Q to R, R to T, and Q to S and S to T. However, the longest path from Q to T, that is Q to R, R to T, is not a combination of the longest path from Q to R. Let us see Q to R, Q to S, S to T, and T to R. And the longest path from R to T, that is R to T, is R to Q, Q to S, S to T, and T to R, as the combination contains a cycle. This is an example of longest path. Let us see the overlapping subproblems. The overlapping subproblems are similar to the divide and conquer approach. The divide and conquer approach is present in overlapping subproblems. The overlapping subproblems are this property can be used further to optimize the solutions using various techniques. Let us look down and check whether the following problems having overlapping subproblems or not. This is example finding of nth Fibonacci. As from the example we can understand a little bit, like if you draw the recursion tree from F5, that is Fib5, then you will find this results as from this diagram. Now Fib5 is called one time, 2, and Fib4 is called one time, that is Fib5 is taken one time and Fib2 is taken one time. Next, Fib3 is called two times, that is Fib3 is called here and here. So Fib2 is called three times, that is here, here, and here. The next one is Fib1, that is it is called 5 times, 1, 2, 3, 4, and 5. Fib0 is called 3 times, 1, 2, and 3. Now the dynamic programming is used where solutions of the same subproblems are needed again and again. In dynamic programming, pre-computed results of subproblems are stored in a lookup table to avoid computing same subproblems again and again. So dynamic programming is not useful when there are no overlapping common subproblems, because there is no need to store result if they are not needed again and again. From the above diagram, we can be shown that Fib3 is calculated 2 times and Fib2 is calculated 3 times, and so on. This is the end of the chapter. Thank you.